Jai Hind everyone. My name is Pooja Pandey and I am assistant professor in the MCA department in Akgec Garg Engineering College. And today I am going to take a very important topic, that is a program control instruction, and that is basically in the third unit of the computer architecture in the organization if you are studying through the AKTU syllabus, right? So let us start that what do you mean by the program control instruction. See, program control instructions are those instructions that alter the normal sequential flow of the program execution. That means it changes the flow, how or what or how we are going to perform or what we are going to do. It changes the normal flow of the program, and they are known as a program control instructions, right? And normally when we are seeing how the instructions are going or how instruction flow in a simple manner, we see that the CPU normally execute instructions one after the another, right? So but program control, what we know that the CPU is executing the instructions one after the other. But when we are discussing about the program control instructions, as the definition say, that it alter the normal sequential flow of the program execution. So it means that the program control instruction will enable the process to jump, loop, or call subroutines or make decision based on the conditions, right? So it means that the program control instructions normally helps to guide the processor that when we have to change, what we have to do, where we have to do, or how we have to execute the program, right? Now, we can also say that these program control instructions are the part of the machine code and they are widely used in the assembly language programming. Clear? Now, high level, we know that the high level language constructs such as if else, switch, loops and functions calls are translated into these instruction by the compiler. So in short, we can say that the guide, the program control instruction normally helps the processor, or it guides the processor that when, where, how we have to do the specific task, right? So that is a work of the program control instruction. If you want to keep in memory that what you mean by the program control instruction, just remember one line, that these are the instructions that alter the normal sequential flow of the program and they guide the processor that when, where or how we have to do the or how we have to perform the specific task. Clear? Now, as we see that now if we understand that what you mean by the program control instruction, then we should also know that what is the purpose of the program control instruction, and by the definition only we are clear that it control the flow of program execution, because of it is the program normal sequential flow of the program has been changed. That is why we can say in short that to control the flow of the program execution, we use this, right? Now, second point is that we know that with the help of this, we can jump or call the subroutines. So that why it is supporting the decision making and the branching in the program. Now, when we are using the loops, when we are talking about the program control instruction, then it mainly works on the that it normally we say that it jump or it call the value. It means that it execute the repetitive task, right? When it is jumping from one task to the other task, or by the help of the loops, we say that if this condition is true, then this condition will happen. If this condition is not true, then this will not happen. So we can say that it execute the repetitive task or the loops. Now, again, it always it is helpful to call the and return from the subroutines, right? And it also handle the interruption and the exceptional events, because by the definition we are clear that program execution control or program control execution is a technique to alter the normal sequential flow of the program execution, right? So it means that if there is an interrupt or there is any something that processor is unable to perform, that it helps to handle the interrupts and the exceptional events. By it means that where the interrupts occur, it generally changes direction, that where or how we have to take the decision for that task, right? Now, when I am talking about the program control instructions, there are specific number of types of the program control instructions. The first one is your compare instruction. Generally, we say that compare instruction means that we are comparing the two conditions, right? If it is flag is 0, then it will do, but if flag is 1, then this condition will be applied. So here it is same, it is written as that compare instruction is specifically provided, which is similar to the subtract instruction, except the result is not stored anywhere, but flags are stored, or you can say are set according to the result. It means that in the compare instruction, we are not storing any result, right? We are only comparing the results, that it is R1 or the R2, right? Or between, we are comparing between the two things, R1, this is R1 and the R1, that which one will be the best, right? But we are not storing the result, we are only comparing the result. That is in the case of your program control instruction, or you can say that is in the case of your compare instruction. Clear? Now, second is, when we are talking about the types of the program control instruction, the second point is your unconditional branch instructions. Unconditional branch instruction means that we are in the previous slide it was written that when we have to jump, or we have to move, or we have to perform certain task, or when we are calling subroutines. So from that we have taken that there is an unconditional branch instruction, which normally it causes an unconditional change of the execution sequence or to a new location. It means that if some condition is there which is not favorable, so it's just simply you can say it is simply executing that sequence to the new location, right? If I am saying jump L2, it means that move R3 R1 and go to L2, right? What does it mean? It means that we are this location, we are the program counter, or we say that the program is jumping, or our variable our task is jumping on the L2, and the R1, the register R3 and the R1, the data on the R3 and R1, they are just moving towards the this L2, right? So it means that it is a unconditional branch instructions. Again, I am repeating that what do you mean by the unconditional branch instruction? Unconditional branch instruction means that for just changing, or for the unconditional change of the execution sequence to a new location, we are using the unconditional branch instruction, and mainly here we are performing the jump. Okay, whatever we are moving the things, if simply I am writing that jump to A or jump to B, it means that whatever we have to shift our data to the A or B. That is what the meaning of the jump condition, right? Now, if I am talking about the third type, that is your conditional branch instruction. The conditional branch instruction is normally, it is used to examine the values that is stored in the conditional code register to determine whether the condition exists and to branch, or if it does, right? For example, if I say that conditional branch instruction, that simply when we are using in the C programming or in any other programming, we are using certain cases, right? If else, if this condition is true, then this will happen, else this will happen. So these are the conditional statements, if you say, or you can say the conditional branch instruction, through which if the condition is existing, then that thing will be happen whatever we are applying the condition. But if the condition is not existing, it means the whatever the previous task has been done, that only will be happen, right? For example, in the assembly code, that is BER1 and R2L1. Now the compiler, what the compiler is saying, compiler is just allocating R12 for the X and R4 for the Y. Now if we are checking the conditional, now if for the high level code, if this X is equals to Y, then where we are where we are applying the, we are applying again one condition more, that is previously we have studied the third one, that is your unconditional branch, right? So we will go to the branch, we will jump, so it will go to the L1 in the other position. So that is your conditional branch instruction. For the conditional branch instruction, you only have to remember in the mind that we have to just examine the value, we have to just check the value stored in the condition code. Just we have to check that whether that condition exists or not, and then we have to work according to the condition applied, right? If there is a condition is there, then we are going to perform according to that. If not, then whatever the condition we have applied, we have got, we will do our task according to that. So that is what you mean by the conditional branch instruction. Now when we are talking about the subroutines, that is your fourth type of the program control instruction. It means that a subroutine is a program. If I am talking about the subroutine, then what do you mean by the subroutine? We know that subroutine is a type of the program fragment that lives in the user space and it performs a well-defined task, right? And we normally use in the programming world. Now, it is invoked. Normally, subroutine is invoked by the another user, right? Mainly the subroutine is invoked by the another user program, and it returns control to the calling controls on calling the program. So whenever it is finished, so it is just you can say it is just calling up. Subroutine is just the small group or small task is just calling a function, whatever the function is present inside that program, right? So that is what you mean by the subroutine. For example, call and RET, okay? These are the subroutine examples. When I am talking about the types of the program control instruction, there are two more types of the program control instructions. The first one is yours, the fifth one is your halting instruction. See, it's a very simple instruction, that is NOP instruction. What do you mean by NOP? Means there is no operations, right? So it means that it because of the NOP instructions, we say that there will be no change in the processor state, or there will be no adjustment in the processor state or the program counter. It can be, you can say it can be used to just synchronize the sync. If I am saying NOP instruction, it means just it is using for the synchronizing the things with itself. There will be no operation will occur in this, right? So that is your halting instruction, and in halting instruction, that is your NOP instruction. Now, when we are talking about the halt, that is this one, this instruction, it means that it brings the processor to an orderly halt, remaining in an idle state while restarted by the interrupt, trace, reset or external action. Means that halt means that if we want to stop the program, or we want to just you can say halt the program, we are using the halt instruction, right? Or we are using the halt. It normally stops the program, and the program after stopping, you know, or after the halting, we know that it will only be restarted when we are just producing some interrupt, okay? Then only, or we are resetting our device, or we are using some external action, then only the processor will restart, okay? When or we have to just revoke the halt instruction. Now, when I am talking about your interrupt instruction, what do you mean by the interrupt instruction? See, first we have to understand that what is an interrupt. Interrupt is a mechanism by which an input, output or an instruction can suspend it to the normal execution of the program and get itself service, right? Interrupt means this, you are stopping a program or something to do that task, right? You are just interrupting. Like now I am giving up the presentation to you all, right? Now if certain electric failure or something happen, my presentation will be stopped, right? Until what time my presentation will be stopped? Until some interrupt will occur. Interrupt means that again the light will come, again I am starting, so that due to that interrupt I have started my presentation again. So that is what you mean by the interrupt. So interrupt, we can say that interrupt is simply a mechanism by which an input, output or an instruction call can suspend the normal execution of the processor and get itself service. Now there are many types of the interrupt instruction, but here we will study these three, that is your reset, trap and the int r. Reset means it normally when our program is stopped, suddenly we have program, how we are going to start? We are just resetting it, right? We are just restarting it. So that is what you mean by the reset. It simply reset the processor, and it may include any or all setting of the registers to an initial value, or we can say it's setting the program counter to the standard starting location. That is what you mean by the reset. Now, when I am talking about the trap, trap is nothing but it is a non-maskable edge, if you say, and level triggered interrupt, right? And when we have to keep in mind, when we are talking about the trap, trap is considered to be the highest priority, and basically it is a vectored interrupt. When you are going to study the interrupt in the very detail, you will find that there are the two types of the interrupts. So one of the type is your vector interrupt, and trap is considered to be the vectored interrupt. Now when I am talking about the INTR, it means that it is a level triggered and it is a maskable. Now again there are two types of the interrupt, maskable and the unmaskable. So INTR, it is a, if you say that it is a labeled trigger, right? And you have to keep in mind that it is a maskable interrupt and it has a lowest priority. For trap it is an highest priority, but for the interrupt it is a lowest priority, and it can be disabled by resetting the processor. So when you are resetting the processor, we can disable this INTR, this kind of interrupt. So these are the types of the program control instruction that we have to keep in mind when we are performing or when we are executing certain tasks, right? Now, if you see these diagram or this flow chart, which is clearly depicting that what is a normal flow and what is a control program flow. Okay, now in my left side, if you if you see in my right side, if you see that this is a start, instruction 1, instruction 2, instruction 3, and here it is an arrow, sorry, here it is an arrow. So it is an AND, right? So what is this? This is a simply a normal sequential flow. If you are saying it is just following the sequence, or it is just following the path that how it has been started. That is, first we are starting the program, then we are doing the instruction, then again we are following the instruction, then again we are following, and the program has been stopped, right? We can say that start A is equals to 1, B is equals to 2, there C, we are taking sum is equals to A plus B, and here we are writing that sum is equals to this, and then it is a stop. So just we are saying that when a certain condition is there, or we are just simply following the normal flow or normal you can say normal control flow we are talking about, or normal sequential flow, then it means that we are following this one in a straight. It is simply just following the sequence, if you say. flow. If I say that, it means that if you see that there are certain conditions are there, if you see that we are jumping also, we are filing the condition also that yes or no, it means that we are starting from here, then we are following the instruction 1, then we are checking the condition if whatever we want to say, and if the condition is checked yes, then we are saying that it is a we are going to jump to X, right? But if the condition is no, then we are following the instruction 2. Here it is coming, and then we are following the instruction 3, and then we are going to instruction N, right? We are going to instruct N. So this is a control program flow, and if you see that here, it is simply just changing the you say it is just changing the sequence of the program, right? It is just changing the sequence of the program, or just telling that how you have to jump, or where you have to go back, or how or where you have to store your value. From this type of program or this type of flow chart, we can easily understand that what is the difference between the normal sequential program flow and the controlled program flow, right? So now again we have studied that what do you mean by the program control instruction. It means that now I am coming to the topic that advantages of the program control instruction, right? If I am talking about the efficient control program, advantages of the program control instruction is that the first one is your efficient control flow, right? What do you mean by the efficient control flow? First, program control instruction normally provide the processor a way, or you can say a type, that it decide the order of instruction. Okay, it normally decides the order of instruction. It means that branching can be efficiently made, which is important for the complicated mathematics as well as algorithm, right? It normally, see, these type of program control instruction, normally it means that it normally helps when we are working on the complicated mathematics or the algorithm. For example, if I am saying if I have to just add a plus b is equals to c, or sum is equals to a plus b, and we have to store the result in sum only, then we are following the normal. But when we are if you say that when we are working on the both multiplication, or when we are working on the restoring division, or when we are working on a situation where you are just calling the function by, or when we are just using the conditions, right? Here we are using a program control instruction, because it normally just help to find a easy solution for the you can say the complicated mathematics. Okay, so that is what your efficient control flow, and that is one of the most important advantages of the program control instruction. I am saying that it is a conditional execution. Now, with the condition instruction, we say that code can be executed whenever a specific condition is met. Okay, so thereby improving the usability of programs in dealing with the different situation. If you see that when we are working, or when we are working on the conditional instruction, you say if you remember that we are just providing the conditions that if this work has been done, we will do like this, else if we are working in this, then we are doing like that. So that condition we are providing, and that condition, or if of you say, or that loop, or whatever the conditional statement we are giving for the specific task, then it for the different situation we can use the same program because of that conditional statement. So that is why we are saying that this is a second most important advantages of the program control instruction, that is your conditional execution. Now when I am saying the third part, that is your modular code, it means that modulars, what do you mean by the modular? See, modular are especially, you say, the subroutines. Okay, if I am saying the modular code, it means a small part of the program or small modules, or we can say that modules are also are especially the subroutines, where what we are doing, where separate code can be carried. It can be carried by specifying its usage, not usage as most call. Okay, basically it is involving the performing the you can say it is performing the standard functionality as and when required. It means that, see, you have to keep in mind that what do you mean by the modular code? Modular code, when I am talking about the modular code, we can say that the modules we are representing at the subroutines only, right? So where you are just using the separate code for simplifying the, or you can say basically which are more involved for the standard functionalities, and they are used when it is required. That we have to keep in mind, that basically this modular code is basically used when we are required. It is not simply that we are applying all the time. We are just simply using that when it is required. So that is again the third most important advantages of the program control instruction. Now the third is your synchronization. Now if you have seen that we are using the instruction like the halt and the NOP, mainly just it is helping the system, or you say it is protecting from the unnecessary algorithm, right? If sometime the situation occur that we are unable to find that we are unable to find that is it valid that our algorithm what we are applying it is used, we are sometime using the unnecessary algorithms in the program. So this halt and this NOP instructions, it's simply just protect our program and also synchronize our program according to the machine, right? Now interrupt handling, if I am talking about the interrupt handling, now the interrupt strategies normally gives real-time competencies, since they give the processor to attend the peripheral devices and the other kinds of the process promptly, right? So interrupt handling is also a major, you can say it is a major advantages of the program control instruction. Now last one is your efficient resource management. When we am talking about the efficient resource management, you say that we are using the certain conditional statement also. We are just using our program in the in a manner that it is using the less time. So whenever there is some problem, we are using the NOP or the halt instruction, we are using the interrupt. So that helps it helps directly or indirectly in managing the resource. So it also helps to increase the performance. So what the basic thing the CPU needs, right? When our CPU is giving up a high performance, need less time, it means that our machine is very right thing, right? So that is what the program control instructions advantages are there. So now we will come on the disadvantages of the program control instruction. It is, first one, I am saying that it is a complexity, right? If you see that in normal sequential program flow, we are just simply following the step 1, step 2, step 3. But in the program control instruction, we are just following the control, you can say conditional statement. We are following the control statement. So they are mainly something, you can say they are very complicated in writing. Certain things are written very complicated, and we have to understand that complication, and we have to design our processor according to say that. That is why we say that the program control instruction is a little bit of the have the complications, or we say that it is a complex, right? Now second one is your program overload. when we are using the, if you say we are using of the control, conditional controls, now we know that the use of the conditional controls and the subroutine calls has its certain drawbacks, while when we are using the branching or moving back to the previous status, especially in the nested calls and excessive use, it can provide a certain hindrance to the program, and that will also affect the performance of the CPU. Now, there are the risk of the errors. When we are identifying the error in the program branching, and which is supposed we are, you can say, which is not supposed to, or abuse of the interrupts can lead to errors. Such programs, or you can say such loops are, you can say, they are unable to, we are unable to just fix the problem. Okay, so that is what your risk of error we say, and that is again a disadvantages of the program control instruction. Now, if I am saying the dependency on the processor architecture, it means that it is a type of the instructions that are very particular with the processor architecture, and it means that software cannot be run on the different hardware platform because it is dependent, right? Now, if I am talking about the interrupt latency, it means that it is handling the interrupt that are some particular latency. If there is need to be handled, or some priorities are given, then it is unable to handle that thing, right? If last thing is that overhead with the subroutines. Now, there is a little doubt when we are using the subroutine, how the code are organized, or how we are saving the time, or too many transaction between the subroutine and the main program. It normally wastes the time and within the stack management. So, these are the, you can say, this is the disadvantages of the program control execution, right? So, this is the this is what I have explained, that what you mean by the program control and program control instruction, what are the types, what are the advantages, and what are the disadvantages. So, whenever you are working on the in terms of the computer architecture, or when you are just working on the conditional statements, you simply something will click in your mind, that how a program control instruction works in our system, right? So, thank you all, and thank you everyone.